Vinegar.
Yeah.
The lights are not coming on.
Okay, we'll just go through it and see how to go about it. And Leilani?
Yes.
Awesome. So, and where is Imani?
She's joining the meeting.
Okay. Was she able to do it as well?
Yes.
Okay, that's nice. So maybe I think we'll so did you follow, did you try doing like different seconds, like there's something different?
Yeah.
Okay, I think maybe we'll just see what everyone did, how they went about it, so that everyone gets familiar with that. Vin, did you manage to do it? Ben, you can hear us? Okay. So, okay, so so I think maybe we can start with Sean. Sean, you can just share your screen and yeah, maybe just take us through what you did. You did, and then for the sake for even I'll just give you some tips on, because now we'll get a bit deeper into more complex circuits. So I'll give you some tips on how to troubleshoot. Yeah, so I'll give you some tips on how to troubleshoot, because we'll be doing a lot more complex circuits. So for everyone else, those who have not been able to do, I'm sure it's just something small maybe that you missed. So I'll show you how to do that. Okay. So just Sean, share your screen. Just take us through. Okay. Switch on your mic. Just take us through what you did with the code. I hope you remember to save.
Yeah. The phone. Sorry for distracting you. Oriedo. This cut. If you eat after you've eaten.
Sean?
Yeah.
You can just start. Just take us through your program. Open your program. Yes. So,
forgot to save it.
okay, so that's the other thing. You always make sure you remember to save it. So always you remember the buttons we showed you. I showed you. So always click on once you've had. Even sometimes the program crashes. So just try like you can just save the program occasionally. Like if you do something and it works, just save it. When you're taking a short break, just save and then continue. Okay. Maybe Leilani, you can just share. Leilani, you can just share your screen and then just take us through what you did. Yeah, just step by step the whole program.
So when I first got it, it was the pin mode, and then instead of 13, it was LED bulletin. So I changed it to 13, and then I copied the same and then made it 12, and then I made it 11, and then I did the same for the bottom part.
Okay. So, and do you try, so do you think, like, for the traffic lights, like in Nairobi, do they operate like 3 seconds? Do they operate in a similar way, or is it slightly different?
I think it's slightly different.
How have you seen the counter? It usually counts. How many seconds?
I think it's normally a minute or a minute and a half.
Did you try like 60 seconds?
Yeah.
Okay. So that's nice. So that one was just maybe a brief one on the traffic lights. We'll have maybe a short challenge today, and I want you to use the red and the blue, and then we'll try simulate police lights. Right? So the same way police do, like when you see a police car, it has the blue and the red blinking. So we'll try do that, but now with the Arduino. So okay. Imani, you managed to do the same?
Yes, I did.
Okay, that's awesome. So, but I think the program structure is basically the same. So, for the sake of the other guys, so we'll just let me just try. We just go through the circuit again, and I'll just give everyone some tips on how to go about everything. Okay. So let me just get the circuit. Okay. So I think, and did Chantel, were you able to upload to the Arduino? It uploaded successfully.
No.
What maybe just share your screen. Let's see what was the challenge there. When did yours manage? Did it upload successfully? Did you save the program? I hope you remember to save. Chantal.
Yes.
Did you remember to save the program? You can just open the one you had saved.
No.
The one you saved. Did you save it? Hmm? Chantal? Sean, maybe you can just help her see if she can open the program. Ben, did you manage to upload? even the basic one, the blink sketch. Sean, you've been able to do that?
Refusing.
Okay. It's refusing to upload. So just go to tools. But there's also a problem. The program is not completed. So just try check also, make sure the program, or open an example, open the blink example. Make sure that is working first. Is that working? Or go to file. So go to file. I think it was right at the top. I think maybe just minimize the screen and you'll see it on the top bar. Sean? Okay. Then also for Ben, yeah, exactly there. So make sure it's okay. Tools. So that one is okay. So now just go to examples. Go to file, examples, blink, basics, and then blink. So I think it's opened another program. So you just close this one and then share that one. So always remember to save. You might do a lot of work and then when you close, it will disappear. Okay. So don't forget to save. Have you closed? Okay, and then now share the new one. So for everyone else, when you get an error, always right at the bottom, it will tell you what the error is. So just confirm again on tools and make sure that you have the right board selected and also the port. So that's okay. I think that shows okay. Everything's okay. And then now click upload. Shall tell you following to see how to do it, right? Okay, and then upload. Error. Okay, just okay. I think there's a problem. Just go back to tools. For the board, then that's okay, that's correct. Then for port as well, check port again. Okay, then okay, and then click the first line. I think so. Okay, just click on the compile. It's the tick. Yes, verify and compile. That one as well. Okay. I think there's a problem there. Because everything is correct. So it could be maybe probably issue with the program. Okay, just a minute. For that, maybe when you can share your screen. Let me just check on the issue on for Chantel's board programmer. When you can share your screen. Oh, okay, that's okay. Okay, so let me just take you guys through. Let me just take you through this. So this is where we blink. Okay, so I hope you can all see my screen. So like I said, always so you can get a number of examples here, but once you have now the program, always go to tools, make sure you select the right board. Yours will most likely be here, so just the same way you've been doing. Then make sure you have the correct COM port as well, and then once you have the program, before maybe you even upload, you can always just check. Unless maybe there's a different problem, that's when we're going to maybe try troubleshoot. There could be an issue with the drivers, but I think you've already gotten used to this one. So once, if it tells you done compiling, then you'll know. If it tells you done compiling, then the program has the program is okay and is ready to be uploaded. If, for instance, like I told you with the C++, you always have to remember the semicolons. If you forget that and then you do compiling, this is what will happen. It will compile the first part of the program, but then it's going to tell you that there is a problem. And most of the time it will even point to you where the problem is. So like in this area, so first thing it's going to draw like this is more like light red color below the line where it sees a problem. So when it sees that problem, so it will draw a line below where it sees the problem, and then after that, below here, it's going to draw for you. It's going to actually write what the possible solution is. So for instance, here we removed the semicolon. The semicolon here, and it will tell you it expected a semicolon before the closing brackets. So basically that's what you're supposed to add. So most of the time, just look there, it will give you a hint. This is usually a very important part of programming. We call it debugging, and it will help you to be very good at programming. So always just be, yeah, sometimes it will be discouraging when you see it, but it's actually good because you now get very good at programming. So just check here, check at the bottom, it will tell you what the problem is, then correct, and then do it again. So for the program, I think it will be the same as what we had shared. It will be the same as what we had shared, but the other part that will change is this here. So let's just go through the connections again. So for the guys who had trouble doing the connections, we'll just guide you through how to do the connections. But there's also something else we're going to introduce today. So we'll do for one LED. So I'll use the same program we've been using to. Okay, so there's this very nice program we've been using to do the simulations here. Okay, so there's this program we've been using to here. So first thing is a breadboard. So this is probably the same thing you'd be doing physically. So get your breadboard. So always, so this is basically the same steps you're going to follow. So always grab your breadboard first, and then the other components that you need follow. Okay, so after that, then you're going to grab our LED. Make sure you know the direction when you're doing the connection. So there's the long leg and then there's a short one as well. So like this. So remember to check the long leg and the short one, and then you'll grab your resistor. So when you check the color codes, you'll make sure you're using a 220. So for the resistors, the LEDs we're using, 220 is sufficient for what we are doing at the moment. So make sure you always grab 220, red, and brown. Then the next thing is, then the next thing after doing that will be now getting the Arduino. Okay, so that's this one here. So also make sure you're checking the colors. So the example we did, we were using the three digital pins. So make sure you connect one from 13 and then goes to the LED pin, and then the next one goes from here to here. So the places where you'll actually, the instances where you'll actually have a problem is when you're doing these connections. Always remember the direction on the connections on the breadboard. This is how they move. So this, from this to these connections here are the lines here are parallel. So number 1 all the way to number 60. So if you connect resistor to this pin, then you'll also connect the other pin to this point here. And then for also this as well. And then the other thing you do is make sure that you've pressed in, make sure you push it in completely. And then before you even do, the best way sometimes is also, you can upload the program and then just test one LED first. So you test this and then connect your, test this and connect your Arduino to power. So if you connect your Arduino to power, then if you have the right program, this is what will be happening. It will be going on and off, on and off. Okay. Anyone with a question? Anyone with a question on that? So in your boards, I want to introduce a few more components today. Okay. No one has a question. So there's something we call a buzzer. there's something we call a buzzer. It looks like this. So just check Lillian's video. We'll be sharing how it looks there. Just check for, it looks like a button. It looks like a small cylinder, and on top of, on the paper it has it has a plus on top. Can everyone see that? Have you found that? I can just do this as well. Look for something like that looks like this. It looks like this. Really small one, but looks like this. So look for this component. There should be two in your there should be two of them in your board. Okay. Have you found it? Just Sean, have you found it? When Leilani, Imani, Chantal, have you found this component?
Yes.
Okay. Who hasn't found it? Then just check. It has a sticker on top. Yeah, it looks like this, but sometimes it maybe it has a sticker. It might have a small sticker on top. So just check that it's there. It should be in every kit. Okay. So who hasn't found it? Sean, have you found it?
No.
It's not there. Just check. Maybe you can just show us on video what you have. Or Leilani, let me just see what you have. And just show it to us on video. You can see, look at Lillian's video, you're going to see the component is there. There should actually be two of them in the kit. Should have two of them. So just place it. Yes, Chantal has found hers. So Sean, just check. If you don't find it, just you can borrow one from Chantal. Okay. Ben, have you found it? They should be part of the kit, and you should be having two of them. So the other thing you're going to do is just put it the same way we were doing with the LED. Just place it on the board, on the breadboard. Place it on the breadboard, and so what you'll do, you'll see one side has a plus and the other side has no, yeah, nothing really is there. So just make sure you see the plus. So just check this one side with plus. There's one side with a plus. So what we'll do is we can actually, maybe for now, let's just try. Connect this wire here the same way we had done the first LED, and tell me what happens. Just do that and tell me what happens. Last side is a positive. Oh. Okay. Have you been able to do that, Leilani?
Not yet.
Okay, just
May-
yes, sure.
You repeat. Okay.
Okay, just do this the same way we had done the first LED, the first circuit, right? So you'll connect this side is positive where you've or plus where it's written a plus here, and then the other side has no color. So just use, you can use maybe like red here, red wire here, and then the other one to be black. So one you'll connect to 5V, and then the other one you'll connect it to ground, G and D. Okay. Okay, so the other thing is just make sure, okay, so this is a bit big, it's a bit wide. So when you place it here, you will not maybe see where the legs have gone to. So make sure you see where the legs have gone to here. Take note of that, and then the wire should go here. Sean, have you managed to do it?
Yes.
What's happening? Uh, um, or just tell me what's happening from the buzzer. Is there anything you can see here on the buzzer? Imani?
Nothing's happening.
Okay, so the other thing I've seen is it's possible to, you might actually maybe just make sure so just make sure you have let me just show it from Lillian's video. Let me just have a look at Lillian's video, so you can maybe just click on it. You can look at Lillian's video. So this it's just let me just stop sharing and then just double click. So just okay, just double click on Lillian's video. You're going to see what we'll be doing. So first thing is you can take the LED, take the buzzer and place it, place the one leg very close to number 20 or maybe like to the last row. Okay. So you can see it there. So that when you push it in, they are like four holes apart. So the negative will be, or the side that is positive is now on. Just check, you can remove and see where the positive is going. I think it's easy if you start with the wires. So put the wires 4 holes apart, like one on number 1, and then the other one on number 4. Okay, one on number 1 and the other one on number 4. Chantel, you can see that?
Yes.
Okay, so now just do that, and then after you've done that, then check the side that has a plus. The side that has a plus, put it on the side where you have the red wire. And then the other one should go in on the other side. And then if you have the red wire now, the red wire, put it on 3 volts, 3V, 3.3. So just put it on 3.3. You can hear mine. It's making a sharp sound. And if you take it to where pin 13 was, you'll actually hear something else. So you see, so it will be in sync with the LED. So try something, it should look like this. Yeah, I think I see the smile on Sean, so it must have worked. Yeah, so Sean, it's working. It's very loud, eh? Okay, so if it's very loud, you can just remove, and then we'll see how to work with it. That's nice, Sean. Okay, Leilani.
Yes?
So it's working, right?
Yeah.
Okay. Leilani. Imani.
No, I'm still working on it.
Okay. Ben. Ben, have you managed to do it? So this is just have a look. This is how you do it. So just look at the video here. You'll see. You have to make sure. So this is the 2 legs here, right? So put. I think it's easier when you start with the wires. So just start with the wires. Place one the black one first, or the one that's supposed to go to the other side. Then count 4 holes. 1, you see here from here 1, or basically here 1, 2, 3, 4. Then connect the other one there. Okay. So for Imani, just follow this. So place 1 there and then count 1, 2, 3, 4. And then once you've done that, take the buzzer, make sure that you see the plus side. So the plus side should go to where the red color is. Then now connect it here. Connect it so that now they're in the same position as, yeah. There was the sticker that was there. You can just leave the sticker on there. It's usually a bit loud. So yeah, so you will hear it do that. Okay. And you see now it goes, it will make the sound every time you do that. So this here is what we call a buzzer. So it's an example of an output, of which this is an audio output. The ones we've been looking at are visual outputs. So those are like LEDs. So for audio outputs, this is what we use. This you can think of maybe how you can actually combine it in various ways. Like you can actually like for instance combine this with maybe a sensor. So for instance, if you sense if like we're going to use an ultrasonic sensor where if something comes close, maybe then a sound should be made. Like you could picture like using this as an alarm for maybe like as a burglar alarm in your as a burglar alarm in your at the door. If someone comes to the door, then it makes a sound. Or even a more interesting, now that we're having the online classes a lot, you can place it near you, and if someone comes near you and is maybe wants to interrupt, then it makes the sound, so they know they need to maybe move away. Okay, so yeah, so I think I just want you to, you remember we said we want to do the side, the more like the police siren. So this is what we are going to do. So I want you to have 2 LEDs, the blue one and the red one. And then blue one and the red one.
Don't have a blue LED.
Just check. There should be around 3 blue lights, 3 or 4 of them. But just check in maybe in Chantel's kit. You can borrow a blue LED. So just place it somewhere like that. Then get another resistor as well and do the same. And maybe if you don't find the blue LED, it's maybe not necessarily a must, but you can try yellow. Maybe that one is an ambulance. Okay. So
I
what
also
we
don't have.
Okay, let's try. Just use red and yellow. What colors do you have? I think there might be colorless ones, but now when you put them in, they are going to show with a different color. Okay. So is that working? So just put two LEDs. Connect the same way I've done it here, and use again. We're going to use 220 resistor on both of them. Yes. So the other thing we're going to do is so now just disconnect this. So we'll put this. So the positive side, you can connect it to. So we have the buzzer, and we have the buzzer, and we have the LEDs. Okay, there, and then so do a connection similar to this one. Yeah. Then for these colors, you can use different colors. But now what will happen, it will be similar to the code we had, but I want you to play around with the delays so that it does this really quickly, and it also makes the sound like more like a siren. It goes on and off like really fast. So it's making a sound teet, 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 teet. So that probably, like, assuming this was on top of this was on a police truck, then it should actually be sounding like a siren. Sean, have you been able to do that?
Yeah.
Okay, so now just get into the program. Chantel?
No.
The connections. Maybe you can try just join Sean, and then it's usually sometimes easier when you also work together. Just join Sean and work on the connection. So when you get lost, maybe it's usually a bit easier to get someone to just show you what they've done. Imani and Leilani, when have you managed to do this?
Not yet.
Okay, so maybe have you been able? Okay, or at what point are you at? Okay, but the other thing, I'll also share this circuit, because this will be like a challenge for you. So you have, so we'll slowly be introducing new boards every day. Yeah, the new I'd call them actuators. Or so you remember we had a look at two components of a robot. There is sensors, and then there is actuators. So we'll always be introducing a sensor and an actuator every time. Okay. Okay. So just Leilani, have you managed to do the connections?
Not yet.
Okay. So I'll send this. I'll send this as well after the class, so everyone is able to do that. Maybe I can just introduce another one. There's something we call a servo. So if you look for on your board, you'll see there's something that looks like this. In your kit, there's a blue something blue that looks like this. Have you seen it? It's written micro servo on it, and it's blue. Have you seen it? So servos are they're very interesting. Yeah. And then also inside the box, there is also some plastic parts for the servo that look similar to what is on the screen here. So you can maybe grab one and actually just place it on the servo, so it looks the same as this one. Have you managed to do that? So these parts, just look on Lillian's video, you're going to see there's these parts that look like this. There's some white components. You can just place it on top. And so what basically a servo is, it's usually a motor inside, but it usually does like 180 or 180 degree rotations. So it will go to one position and then come back to the other one. So it just basically that's basically what it does. So I'll show you these two and the code to use as well for them. But then I'll want you to so the challenge I want you to do is you'll write the code for this one, and then I'll show you the code for the servo as well, and then you'll try to combine the two as well. Okay, so servos, they are used very many places. These days we have smart doors where you can just like place your card and the door opens on its own. So like the lock unlocks itself on its own. So this is what is used inside. And you can use it for so many things, even like you can attach it to a tap and you'll actually be able to switch on a tap remotely without you being there. So this is also one of the major components in robots. Almost all robots always have servos in them. So this is a very big component or a main component to actually use. The way it's usually connected, at the middle, it usually has, in the middle, it has the power. Then here we'll connect like the signal wire, which will most of the time you'll see it's yellow. And then the other one is ground, which will be black, like this. So this is how we'll always do the connections for a servo. Okay. So then yeah, so you can, this will sometimes be black or it can be brown, dark brown. So but you can use any color. So if you see, hold the cable, you'll see there is black, red, and yellow. So what we do is we'll connect this to probably maybe like 6. You can connect this to 6. That's the signal line. and then this one goes to so okay, we can just do this in a new connection. Oh, okay, just so for the servo connection, this is how it's usually done.
I can't find mine.
The servo.
Yeah.
Okay, the kits should be having, maybe just check your kits well, because okay, but does Chantel have?
I don't think so.
Leilani, Imani, and Ven, do you have servo? Yeah, yes.
I haven't found it yet.
Okay, just we'll take a picture of it and send it to you. So you should see something. It's a small component with blue. That's blue. It's blue, and it's you can see the component inside, and it's written microservo. Okay. So basically, this is how you probably do the connections, but I'll just share this, and you'll be able to do the connections. It's the program is usually a bit. You'll be able to see the program here. So when you come to Arduino, again, samples. So you go to Arduino, you're going to find a program. So in Arduino, what you'll see is this. Under file, you come to examples, you can just scroll down all the way, you're going to find servo. So for under servo, you select sweep. So yeah. Okay. Chantel found it. So Chantel just show Sean, and yeah, see if you can find the same component. So for how you drive a servo, this is really how you drive it. Huh? It's a very simple more like program, but you just do the same thing like we've done on the same thing that we've done on the LEDs. But now here I think you've learned about variables, and only that here now we'll actually write the actual code. So in this and then and we'll set the position to 0. So once we set the position to 0, then when you're setting up, we're going to tell it where we've connected the servo. When you connect the servo, we'll connect it on pin number 9. And then always remember, when you're reading through this program, these are the comments on how it is actually happening on the program, right? So this is just basically what you can, if you want to understand what's happening, this is the same thing. And also the other thing is you are introduced to loops. So last time when you're doing the program with the app you did loops, for loops, while loops, if statements. So for this instance, since what this program does is basically like swipes the servo, it will go to one direction and then goes back, more like the same way a wiper in a car does. So it goes one side and then goes back, one side goes back, one side goes back. So this is basically it. And for position, which is POS, we will slowly increment from 0 all the way to 180, and then the next line just does the same, but it now goes back. So you'll try do these connections. I know maybe it's a lot to do in class, but I'm sharing the circuit and the code in a few. So you'll be able to actually use this, do the connections. Challenge for today, between today and next week is I want you to do simulate police lights, and you simulate police lights with a siren now that you can do the connections. If you have a challenge, please just notify me, like I'll check on Chantel's laptop right now in once we're done with the class, so that she's able to do the uploading. Okay, so yeah. So when I'm going to upload on mine, you're going to see. So my board is slightly different. So mine is on Maker. So just check on Lillian's video. You're going to see what the server should be doing. So yep. So upload. So like I said, always make sure you have the right COM connected. And then click upload. You'll see it will do this, and then it will say finished. So just look at Lillian's video, you're going to see what it's doing. So if you do the connections right, this is what it should be doing. It should be rotating clockwise and then anti-clockwise, clockwise, anti-clockwise, okay? So it's usually quite interesting, because now when you combine this with the other sensors, you'll actually be able to, like, you can even put maybe like a light at the top end. It's shining on one side and slowly moving on the other sides on its own, on both sides on its own. So yeah, okay. It's too much for today. Or let me share the circuits. So just try them out, and yeah, you'll just tell me what you find. Okay. Not here. So I have something I wanted to share, just a video. So I have a video to play today. So just have a look at it, and yeah.
Someone had talked about automatic cutting drawer. Was it Leilani or Imani? When we started and we said expectations or what robots or what automatic systems you'd like to do, someone talked about cutting drawing. Was it Leilani or Imani? Leilani, was it you?
Who did what?
When we started and we said some projects you'd like to do, someone talked about cuttings, automatic drawing of cuttings.
Oh yeah, it was me.
Yeah, so using a servomotor, you can actually do that. So maybe you can start thinking through how you could possibly use a servo.
Okay, so I have an interesting video for everyone to watch here. So just have a look, and I hope you enjoy and get inspired by it. And then after this, we'll just move to the next class, okay? If you can't hear the sound, just wave at me and then I'll adjust everything else.
I'm Rohan and I'm 12 years old.
He knows more than most PhD students. Google had given us a big box of robot parts. So I kind of expected I would give him these things and he would fiddle around with it for a while and come back frustrated or say, oh, I can't do that. But I was totally shocked. Like at the end of the day, he shows up with a working robot. Ultimately, he developed it into a system that could basically drive around the office and deliver chips from room to room. It would like drive into various offices autonomously and say, do you want some chips? And it would just do it, and it didn't run into anything. It would avoid people, and he did that, just within a week of being here.
You can imagine like this actually, like right now with the situation we have in the world with Corona, such a robot will be so useful because we are having problems in hospitals where even medical staff are getting infected. So if you use such a system or such a robot, you'll be able to actually deliver food or medicine to patients without having very close contact.
And it didn't run into anything. It would avoid people. And he did that, just within a week of being here.
Somebody gave me a giant box of Kinects for my birthday. I started with the diagrams because I've never done anything like that, but I'm like, these are lame. And I can make something better. HTML was like my first language. My mom showed me Google for the first time. And I'm like, you can search for anything? And then I was like, cool with Google. And then I'm like, how could I make something like that? So I actually moved on to hardware because then I started getting to the point where being so small and not knowing much about math and stuff, I couldn't make anything cooler. When you see people's expressions, that's really cool. And you when people walk up to you, it's all like, what is this doing? So I would say, what do you want to do? And then give them the appropriate language that they would want to learn. And then through that, you can get something to come alive. It could be a robot, it could be a website, it could be anything.
Yeah, so it's a simple video, but yeah, you can see how far this can take you. And literally, like I told you, you'll become magicians, or it's more like superpowers you have. So, and you can do anything, literally anything you want, and build anything and most importantly, to even help people with most of the problems that are there in the society. So I think with that, we'll just stop there for today. I'm going to share the circuits that we're supposed to do. So that you start, so you're able to do this experiment on the servo, and then also do the police lights. Yeah, okay, that's awesome. Anyone with a question? For Vin, maybe just let me answer your question. So for the breadboard, it usually has numbers. So you can they just help you to at least know which row you're using. So I'll maybe just use one here. So like the breadboard we are using is similar to this one here. It's similar to this one. The good thing, the simulator I'm using here actually shows you how the connections are done. So the ones at the top, these ones here, they just connect all the way straight, all the way to the end. And these are the ones that we use as power. These are the power pins or the power lines that we'll use. So you can just connect the 5 volts and the ground here. So minus is usually ground and plus is usually positive. So yeah, and then for okay, and then for the numbers that are here at the top, they're just basically counting all these lines So all the way from here, number 1 until number 60. But these lines go this way. They connect this way. They are opposite to these ones here. So this here, you can actually see how they are connected. So if you connect to number 60 here at the top, that's 60A, then you connect the other connection to 60E. So everything should be 60. 60, if you connect now, like for instance, where we've done the breadboard, okay, where we've done the buzzer, when you connect it to 60A, then the wire should go to 60E. Okay. And then the other one is on the Arduino. So for the Arduino, it also has, so let me just zoom to this. Ben, you're saying yours doesn't have these numbers? Because the Arduinos, all of them should have this 13, 9, all the way to 0, and these ones as well. Okay, you'll just send us a picture of your board and we'll have a look at it, okay? Yeah, but it should have these numbers and they'll help you a lot in doing the connections. So like when you say number 9, number 1, but if not, they are usually just standard. They're usually standard and you can be able to actually just follow, just count all the way from this side is 0, going up all the way to 13. And then from this side, count this A0 to A5. And then just count correctly, but make sure you don't make the mistake. Make a screenshot of this. You can make a screenshot of this. It usually helps a lot. But anyway, if you have a question, you can also contact me or Lillian. We'll be able to assist. Okay. Sean, are you okay?
Yes.
I hope you're excited to do the traffic lights and the servo. Okay. Yep. Leilani.
Yes.
Imani. You're looking forward to doing the connections for the traffic, for the police lights?
Yes.
So I think what you can do is you can take a short video and maybe share on email once it works. Yeah, for everyone. Yes, and it should also have the buzzer there with the siren. Okay.
Okay.
Same thing. So Imani as well. You okay?
Yes.
Okay. Okay. Then I think then we can just end it at that, and then
Okay.
go to App Inventor. Okay. The other thing is Lillian has shared a link. The simulator we're using is called Tinkercad. It's very nice for playing around before, if maybe like sometimes we're having issues with the connections. You can try and do the connections there, and then once they are working there, then you just replicate the same thing. Just repeat the same thing. Okay. Yeah. So I think that's it. Yes. Mhm.
Hi, everyone. So we want to get started on App Inventor. I'm trying to share my screen. But I just want to hear from you. What were you able to do? Sean and Chantel were okay by the time we ended the class last time. I want to hear from Leilani, Imani, and Ben if you are able to do the game. So we did a game that we called Coin Collector. So basically it had a sprite or our little person who was going around collecting the coins. So Leilani, were you able to do it?
Not yet.
Imani?
Not yet.
Ben? So Ben, I think she's going to chat and let me know. So, So today we wanted to add a timer to the same game. So I'm wondering if we should just continue and then I'll catch the rest up. What do you think?
Yeah.
Is that okay?
Yes.
Kimani, what do you think? Okay. So then I think we will have to, okay, let's just repeat for the sake of the ones who are not in that class. So let's go to MIT App Inventor. Are we there? Why am I not able to share my screen? Wazima meeting. Co-host. Hata sioni meeting.
Sorry for that. So, okay, Leilani is host. Please proceed. Okay. Sean, can you hear us? Okay.
Can you hear me?
Sean, Leilani, Imani, can you hear us?
Yes.
Okay, I don't know. Something happened. Sean and Chantel dropped off. Okay, let's just maybe as Lilian will just proceed, and then let me just try get them back.
Okay. So can you, I hope you're seeing my screen, Leilani?
Yes.
Okay. So in the class that you missed for MIT App Inventor, we went through variables again, and I also introduced statements which are used in programming. So we had said that variables, we have two types, global variables and local variables. So we said global variables can be used anywhere in your program, and local ones can only be used within a certain function. And I had showed you. Then we talked about functions, and we said that functions take arguments and return values. I also showed you how to come up with a procedure in App Inventor. And we said a procedure is a set of blocks that together can be run and they return something. So then in the class that you missed, we talked about statements. And we said statements express the action that is to be carried out. And we have two types. We have simple statements and compound statements. So as the name suggests, simple statements are short and mostly they consist of just one word. So an example is call, and an example when you use it is called procedure. Then we have return. An example when you use it is return a value. Then we have go to statements. So for example, you'll say go to a certain procedure. Then we have assignment statements, which basically assign variables. Like when you were in Arduino, there was a part where you're saying int pin, you are initializing pins and assigning them to a certain component. So yeah, those are the ones, those are now assignment statements. And then we came to compound statements, which are a bit, now they consist of more than one word, and they now do more things than the previous simple statements. So an example is when, do. You remember when we did the game for SpeechBot, we were saying when button 1 is clicked, do the following, call a message. Yeah. Then we have for loop, which you've just talked about right now. When you were talking about, was it the buzzer or the lights?
Join.
Yeah. So basically a for loop will do something repetitively. And like for the game, we are going to see, we had 10 coins. And so it was repeating what it does to one coin, it does it to all the other coins. So then we have if then. So an example is if A is greater than 3, then write line A. Else, write not yet. Then we have another statement, if, then, else. So the more complex the statement gets, the more things it can do. And then we also had do while loop. So now in the last class, we made a game and we called it Coin Collector. Chantal, just share your screen for the game we made last time. So you can go to my projects, and then under my project.
You're sharing your screen.
Let me stop.
Share. Is it?
Hey, Chantal, I see you've even added a background image to your
Yes.
screen. Wow, that's nice. Okay. So you also change the colors of the balls. So when you play, it says game over, good trial. Good job, Chantal. You collected all the coins. And then it can restart or cancel. Wow, you've really done a lot. So maybe we can just see your blocks.
Okay.
That's really nice, Chantal. Ah, oh, so you added button 1 and button 2.
Yes.
Wow, that's really nice. So today I had wanted to introduce the concept of using a timer. So now when you play the game, now we also want to be able to set a time within which the game should be over. So since some people have not been able to do it, I'll just talk about timer separately. And then when I catch them up, they're going to add a timer to the game. And then Chantal, since you've already done it, you're going to now add a timer. You're going to add a timer to the game. But let's talk about timer, using timers. So just stop share. I want to share my screen.
Okay.
So let's create a new project and call it timer. So start new project, call it timer. So the first thing we do when we're using timers, so one thing is we need a clock, because basically a timer is being able to count and set limits and decide how long the period should be. So let's go to sensors and pick a clock. You drag and drop it to the screen. So it's going to be an invisible component. So it's a component on the components tab, but on the screen it's not visible. That's how it should be. Then let's pick a label. Label. So for the label, let's go to properties for the label. And let the text for the label be 30. So we want our timer to start counting from 30. And then change the font size to 20. We want it to be very visible. You can even make it 30. Make that font size 30. Or 40, whatever size you want it to be. So that's our timer. So on this label is where you'll be seeing the clock. So it's going to decrement from 30 to 0. So 30, 29, all the way to 0. So we've created a label. So we've added a clock and we've added a label, and the text for the label is the number 30, and we've also changed the font. Is everyone able to do that? Leilani and Imani? Leilani?
How do you do the timer for the clock?
Just share your screen. Let me stop share. Leilani, share your screen. Chantal, you've been able to do it. So we created a new project and we called the project timer. Then we went under the palette where the components are, we went to sensors. So under sensors is where you get the clock. Under sensors, no, you already have the clock, right? So it's fine. So under properties for the label, go ahead and change the font size to 20. The font size, you can make it even 30. 30, make it 30. And then the text, are you seeing text for label? Text for label 1, there, make it 30. We want it to be displaying a number, which is now the second. Okay, yeah. So let's go to clock. Are you seeing clock? Just click on clock. We want to see the properties for this clock. So we are seeing the clock will always fire. So currently the clock will always be enabled unless we code otherwise. And the timer interval is 1,000. Now that is 1,000 milliseconds, which is equal to a second. So when the clock will start counting, it will count from 30 to 0 seconds. And it will be going like 30, 29, 28, 27, because the timer interval is 1,000 milliseconds, which is equal to 1 second. Okay, so 1,000 milliseconds equals 1 second. So suppose we wanted to count it like 30, 28, 26, we would have made the interval 2,000. Are we together on that? Okay, is everyone there? Sean, are you okay? Sean? Sean, are you okay? I want to hear from Sean, Imani, and Priska. Let's start with Sean. Sean, you're with us?
That is okay.
Okay. Imani?
Yes.
Okay. Priska, just let me know if you're okay.
No.
So let's go ahead and now let's do the fun part, which is the programming. So let's go to blocks.
She's in class right now.
So Leilani, let's go to blocks. We want to start programming our timer. Let's go to blocks. Whose screen are we on? We want to go to blocks and start programming. You see where it's written designer. We said we have two views. One is the designer view and the other one is the blocks view. So blocks here. Okay. So the first thing we're going to do is we want to initialize a variable called global timer. Remember again, we talked about global variables and local variables. We said global variables can be used anywhere throughout your code, but local variables can only be used within a certain function, okay? So let's go to variables. We want to initialize a global variable that we're going to call global timer. So Leilani, let's go to variables. And a built-in, we have control logic and all that. So let's pick initialize global name 2, the first one. So we want to initialize a global variable that we're going to call global timer. Global timer. And we are initializing it to 30 because we want our timer value to be 30. So it could be anything. If you want maybe your game to run for 20 seconds, let's go to math. Go to math and pick the value, the first one. Math, pick the first one. 30. because in this case it's 30. So if you want your game maybe to run for 20 seconds, if you want your timer to go for 15 seconds, if you want it to go for 1 hour, you'll do 60 seconds times 60 minutes and have your number of seconds. So we have initialized a global timer to 30. Another thing we want to do is we want to initialize another variable called start, because we need to say when the timer should start. So let's go to variables again. Initialize global name. So this time we are calling it global start. So this one is telling us when the clock is starting. So, and we want to initialize it to false, because when the game is starting, the timer is not, or when the timer is starting, at first it's off. So let's go to logic and pick false. Go to logic and pick false. So what have we done? We have initialized the timer and we've initialized it to 30 seconds. And then we've initialized another variable called global start, and we have initialized it to false, meaning at the beginning, the clock is off or the timer is off. So now let's go ahead and go to clock. So we want to see what this timer does. So let's look for when clock 1.timer under clock. So when clock 1.timer, yes, that one. So what do we want our timer to do? So this is one remember we've just talked about statements. We've said we have, this is a compound statement. So when clock 1.timer, do this. So you've said we have when, do, we have if, then, and all those. So we are saying when clock 1.timer, what should it do? So what should our timer do? So the first thing it should do is it should check if global start is true. So let's go to logic and pick if then. No, control. Let's go to control. Control. Pick if then. So when clock 1.timer, it should check a few things. So if, so the first one we want to pick is, we need two things to be true. We need the clock to have started, so we need global start to be true, and we also need the timer to be greater than 0. So anytime when the number is greater than 0, if the number is not 0, then the clock should keep counting, okay? So go to logic, and pick and. Are you seeing the and? And we want two things to be true for the clock to work. So pick and, place it there, yeah. So so the first thing we want to do is we want to say if get global start is true, and also if global timer is greater than 0, that is when we want our clock to work. So let's go to logic again. Pick the one that says equal to true. Just a minute. Pick the equal to one. Do you have an equal to one? Yeah, that one. Put it inside there. So we want two things here. We want global start to be true. So get global start. From global start, when you place your cursor above global start, the one we've initialized there, are you seeing initialize global start? No. Initialize global, yeah, that one. When you place get global start. So put get global start there. So we are saying we want global start to be true. So go to logic and pick true. And at the same time, we want the global timer to be greater than 0. So under math, pick the equal to one, the third one. Yeah, that one. So put it there. And then change it to from, I see where the equal sign is. There's, when you scroll down, just click there, look for greater than sign. The greater than sign. That is equal, that one is not equal, the other one is less than or equal to, greater, yeah, that one. So we want the global timer to be greater than 0. So place your cursor above timer and I initialize global timer. Then it will give you get global timer, yeah, that one. So get global timer. So it should be greater than 0 for the clock to work. So go to math and pick a number. Pick the number, yeah, that one. Bring it and let it fit there. So we've said our clock timer should only work if global start is equal to true, meaning it has started, the clock is counting, and also when the global timer is greater than 0. So when it's 0, it should not continue counting. It should only count up to when it's 0, okay? So if these conditions are true, then it should do the following. 1, it should set global timer to decrement by 1. So the global timer should start counting down, okay? And also, it should display it on label 1. So, are you seeing global timer? Place your cursor above global timer. Pick the set global timer to. Then go to math and pick the one that has the minus. The 1, 2, 3, 4, the fifth one, yeah, that one. So add it there. So we are saying if these conditions are true, we want the global timer to start counting down. So it will do this by doing get global timer minus 1. So get global timer up there, get global timer minus 1. Pick a number from math. So if the conditions are true, we want it to start counting down, and we also want it to display what it's counting down on our label. So let's go to the label. So look for set label 1.text. Set label 1.text. Yeah, join it to, no. Just, it should be under, just below set global timer, no? Below set global timer, yeah, there. So we want this text to be the same value as the timer now. So get global timer and fit it there. Exactly. So we want to go back and set, we want to go back and add a button. So just go back and add a button, button 1. So we want to test and see if our clock is actually working. And to be able to do that, we need to set a condition for when it will actually start. So we'll go like when you tap button 1, it should start the clock. So let's go back to blocks. Let's go to blocks and under button. Say when button 1.click.
Teacher Lillian.
Yeah?
Please give Chantel a bit of time. She's trying to catch up.
Oh, okay. Can she share her screen? Leilani, just stop sharing. Leilani, pick when button 1.click. Who's having a challenge? Share your screen. Okay. So where are we? So set global timer 2. So wait, first of all, Just a minute. Are you seeing where you've initialized global name to 30? That global name is called timer. Change the name from name to timer. Timer. Are you seeing where it's global? So if get global start is equal to true and get global timer, yeah, that way, then set global timer to get global timer minus 1. So get global timer up here. No, and when you place your cursor above global timer, the first statement, no? Okay, yeah, you can put that one. Okay, I see you're ahead of us, Chantel. Okay, so get global timer minus 1. And then set label text. So go to label 1. Go to label 1. Look for set label 1.text. It's down there. That one. Set label 1.text. That one. So set it to get global timer. Okay, so let me just walk you through what we've done here. We've initialized our timer to 30, meaning that our timer will run for 30 seconds. We've initialized a condition called start, where it can either be false or true. So in the beginning of the game, it's false until you make it true. And we've said when clock timer, it should check if the global start is true and if the timer is greater than 0. If the timer is greater than 0, it will decrement it by 1. And then the label will be displaying that value. So we've said we need to add a button. So let's go to blocks and add a button to our screen. Add a button. Add a button, button 1. We go back to blocks. So our timer, we want our timer to start when somebody clicks that button. So under blocks, go to button 1. So when button 1.click, it's the first statement. When button 1.click, so when you click that button, we want to set the start to true because we want now the clock to start counting. So do set global start to true. Set global start to true. No, set. Just place your cursor above global start. Or you can pick that one. You can pick that one. So set it to 0, delete that one. No, delete it completely and then bring another one. Okay. So when button 1 is clicked, we want to set it to true. Go to logic. No, pick the logic true. So I want you to put the when button 1.click above the when clock timer. Just find a way to bring the clock timer down and then let button 1 be the first block. No. Are you seeing how we've arranged it? Because I want it to flow well. I want you to bring this entire block for clock below button 1. Below the... Chantal, no. Chantal, let's go to the workspace. I'm saying, are you seeing when clock 1.timer, that entire block, I want you to bring it down so that after initial global start, we'll have when button 1.click. You've understood me? Okay, are you seeing the word when clock 1.timer? Place your cursor on when, on the word when. The first one. When, place your cursor on the word when. The first when clock 1.timer. The first one. Yeah, that one. Drag it down. Drag the whole block down. Yes, down, down, down. And then let button 1 be the next. So take button 1 up. It's like we're trying to arrange them so that the logic will flow. Yeah, like that. Perfect. So we are saying we are initializing a timer to 30 seconds. And when the game is starting, we are initializing another global variable called start to false, meaning at the beginning, the timer is not counting. And then we are saying when we click button 1, we now want to set global start to true. It's not global timer, it's global start. Change from global timer to start. When button 1.click, set global start. No, set global start. Change from global timer to global start for the one and the button when button 1.click. No, Chantel, when button 1.click, that one, yeah, change it to global start. So again, let me start from the top. We've initialized the timer to 30. And at the beginning of the game, the start is at false. And we are saying when you click a button is when now the start will be set to true, meaning now it will start counting. And then we are saying if global start is true, meaning it's counting, and when the value is greater than 0, meaning it's either 30, 29, 28, what it should do is it should now count by decreasing it by 1 each time. And then the label should display that value. So is everyone here? Is everyone with us? Is anyone lagging behind so that they can share their screen? Sean, are you okay?
Yes, he is.
Okay, Leilani?
Yes.
Imani? Imani, are you okay?
Yeah.
Okay. Hey, then just chat and let me know if you're okay. Then will just let me know through a message. So it's fine. So now we want to test what this does. So let's go to connecting. So connect it and tell me what it's doing. So you should see a button on your screen when you connect, and when you click that button is when the timer should start. So go to Connect AI Companion and connect it with the app on your phones. Oh, so what is it doing? It's counting. Okay, let's see. So when you click the button, I think it's just when you click it just once. Or do you have to click it each time? Just stop clicking. Yeah, I think you just click it once and then it will count. So I want to see what it does when it gets to 0. Perfect. So when it gets to 0, it stops counting. Okay? Because you've said it should only count for values that are greater than 0. So maybe let's go back to our blocks. Is everyone able to see that? Imani and Leilani, are yours working?
No.
Have you connected the app?
Yes.
What is it saying? When you click, it's not.
It's not doing anything.
Okay, share with me your screen. Chantel, stop sharing. Let me see Leilani's screen. I want to see your code. Sean, is yours working?
Yes.
So Sean and Chantel, are you seeing where we've said decrement by 1? Are you seeing where we put -1? You can go ahead and say if start, then set global timer to get global timer -2 or 5. If you want it to, now instead of it decreasing the number by 1, it can decrease the number by 2. So it will go like 30, 28. So just play around with it as I help Leilani and Imani out. So Leilani, set global start to, I've seen it. So when button 1 dot click, set global start, not global timer. Are you seeing there? Yeah, that one. Set its global start, yeah, that way. So now it should be okay. Okay, there's an error. Okay, just let me look at your code again. Just dismiss that and let me look at it again. So initialize global timer, global start to true when clock 1. Just a minute. There seems to be a problem on yours. Dismiss this. I want to see. So when clock 1 dot timer, if get global start, dismiss. So what you can do, Leilani?
Yes.
Go under my project. Open the timers again. Open it again. The operation cannot accept argument true. We'll see another error. Dismiss. I don't know what's the problem because the code is okay. Did you add a button?
Yes.
Is Imani's working? Imani?
It's not able to connect.
But do you have the code?
No.
Okay, I think I'll call you after class and then we can sort this one out because I don't know why it should be able to, it should be working. What you can do, Leilani?
Yes.
Can you connect on Imani's, if Imani has the program, can you connect? You see where you scan the QR code, you can scan Imani's QR code.
Okay.
Imani, share your screen, please. Leilani, stop share. So Chantel, are you playing around with how it's decreasing or decrementing the values? Yes, Imani?
I haven't yet done it because it's not accepting the email because I'm using a different device.
Oh, okay. Leilani?
Yes.
Leilani?
Yes.
Okay, share your screen. So does it still give you that error?
Yes.
Just try connecting. Let's see if it will bring the error. Are you seeing the minus sign on the right? Are you seeing that minus? Are you seeing a minus? Are you seeing a minus sign on the right?
Yes.
Just zoom out. I want to see if probably there could be some code somewhere that's messing things up. Just zoom out. Okay, there isn't any. Okay, just zoom back. Okay, I mean this should work. I don't know why it's giving you an error. So if it continues to give you the error, you can just start a new project altogether, and then we code it from the top.
It worked.
So it's now working.
Yeah.
Okay, so what is it doing? When you click the button, it will start counting from 30 all the way to 0. So let me know when it reaches 0.
It reached 0.
Okay, so are you seeing where we've said set global timer to get global timer -1? When clock 1 dot timer, just come to the code. So what we've done is we've initialized the timer to 30 seconds. We've initialized the start to false in the beginning. And then we've said when you click that button, the clock should now start counting. And then we've said when the clock is counting, it should check if the start is true and if the value is greater than 0. If the value is greater than 0, it should decrease that value by 1. That's why we've said get global timer -1. Are you seeing the -1? Are you seeing the value 1? So go ahead and change that value to maybe 2 or 3. Make it 2. So it'll decrease the value instead of now 20, 30, 29, 28, 27. Now it's going to be 30, then 28, then 26. So you can play around with it to just change how your timer works. So now today's class was supposed to be us adding a timer to our game. But because I still have to catch Leilani and Imani and also Ven, we'll have to do it in the next class. Alternatively, I can send you the notes on how to do it, and then you can see if you can do it on your own. So I don't know if that will be okay. Sean and Chantel, I think I'll share with you the notes for the weekend. You can try adding a timer to the game that we made, the coin collecting game. You can also try, I also wanted us today to increase the difficulty level of the game. For example, you can add the coins from, there were 10, you can add them to 20. And then you can also play around with the speed, which I'm sure you've been able to do. So the first assignment will be add the coins from 10, make them 20. And then the second assignment is to make a timer for the game. Now, I'll send you instructions on how you'll do that. And then you can try doing it on your own. But if you're having any challenges, you can always call me and we're going to discuss it. So yeah, it should be okay. So Leilani, have you uploaded with after changing the value to 2?
Yeah.
So it's going like 30, 28, 26.
Yes.
Okay. Okay. I think that's okay. So I had sent you instructions on how to do the game for Leilani and Imani, but I think it was too much. So I think I'll just have to set up a meeting and walk you through it. So let me know when you're okay to have it between today and next Wednesday. I think we have quite a number of days in between. And we also had set up a quiz. I don't know, were you given a link to any quiz?
No.
So there are some quizzes that we're setting up. So when they're ready, you're going to be sent. And we'll also share notes of the previous classes that we've been having so that you can just, I don't know, just go through them whenever you want to refer to something. And yeah, so let me know when, Leilani, Imani, let me know when you want to have a class, maybe just 1 hour to create the game. Then for Sean and Chantel, you'll be required to make a timer for the game and also add the balls to 20 and also play around with the speeds. Okay. So I want feedback about today's class. What do you think of today's class? How was it? Is it too much? Or are you guys okay? Let's start with who? Chantel.
Yes.
What do you think of the class?
It was fun.
Huh?
I got to understand more.
You got to understand more. Okay, great. Sean? Chantel, it's really good what you've done with your game. You've tried to play around with the components. So you can always start a new project and just try play around with the components that we have and just see what they do. So you can even go online and find out what other games you can probably come up with in MIT App Inventor. And yeah, let's see what you're able to find out. Sean, how was today's class? Sean.
Yes,
How was the class?
it was fun.
How was the class?
It was fun.
We also have the assignment from Arduino where you're supposed to come up with police siren combined with okay, one of you mute you. Chantel mute or Sean. So
Then turn your video on.
okay. So we have the game. Okay, Leilani, let's know what you think of today's class.
It was good.
Okay, it was good. Imani?
I think it was fun.
Okay, she says it was fun. So you are using a different account today?
My computer wasn't working.
Okay, so I think hopefully you can get that sorted out and then we'll be good. So Van will just tell me what she thought of today's class. So just a recap of what we've done. So on Arduino, we've talked about a buzzer, which basically will make a sound. So we've also talked about a micro servo, and a micro servo is basically an actuator that is used for movement. And I was telling Leilani, whoever had talked about the project for a curtain drawer. You can come up with a curtain drawer even using this microservo. So we're going to send you notes or a picture of how to connect it. And then hopefully you can be able to connect. So in MIT App Inventor, we've talked about a game for coin collector. So we'd already created the game in the last class. So Leilani and Imani and Ben are not able to do it, so we'll do it with them. Then we've introduced timers. So probably another way to set difficulty for your game is to reduce the time. So probably you can set the timer to 10 seconds and you've increased the balls to 20 or the coins to 20. So yeah, it's one of the ways you can use to create different levels for the games. Yeah, so I think that's it for today. We're going to end the class at that. And yeah, keep trying, keep playing around with the components you have, keep trying to come up with new projects and apps and games, and it should be fun. Okay, bye.
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 Nobody's leaving. We will continue with the class. You want to continue?